For this video, we'll look at how you can determine where a function is increasing or decreasing, or possibly even staying constant, just using its graph. What I find is that in practice, many people have a good idea as to where a function is increasing or decreasing. Where they run into a lot of problems, however, is actually describing where it's doing this. So to start off, let's get some good tips on how you can describe where it's increasing or decreasing. When describing increasing or decreasing, we identify where that happens by using the x values of the function. And usually these are packaged up into intervals. When we use these intervals, we put parentheses on either side of the interval. We use the parentheses because we do not include the endpoints of that interval. Alright, so let's look at a function and see how this works. To get a sense of where this function is increasing or decreasing, I like to imagine that my function is instead a roller coaster. And so when I'm looking at places where it is increasing, then I'm looking at places where I'm going up on my roller coaster. So I can see on this section for sure, I'm going up in my roller coaster. Now places where I'm going down, those would be decreasing. So on this little portion of the graph, I'm definitely going down. And if it looks like my coaster is not changing at all, I could say that it is constant. So maybe that little flat part over there is where the function is constant. Now when it comes to describing where these places are, we take things back all the way to the x-axis. So this point where it changes is my interval for increasing, because on this entire interval I'm going up. After my little mark, it looks like I start to go down, and then eventually it goes constant. So I want to describe all of these x intervals on what the function is doing. Let's get some more examples and be a little bit more precise with this. So suppose I'm looking at this function and I have to write down the intervals of increasing or decreasing. So think of the places where you are going up on that roller coaster versus the places you are going down. Now let's first track down all the places where we are going up. So this is for increasing. Well, I can see this first portion, I'm definitely going up, and that happens all the way until I hit a -3. So using these x values, I can say that it is increasing from -infinity up to -3. Looks like it goes constant, and then down, so that's my only increasing interval. For decreasing, I can see that it happens between 2 and 6, and it happens again from 7 on to infinity. So I have 2 decreasing intervals. And of course we can also add places where we are staying constant, where we're not going up or down, and it's just our leftover pieces here. So from -3 to 2, and from 6 until 7. So 1, think of the places where you're going up or going down on that roller coaster, so you just know your intervals. Take things back to the x-axis and describe them from the starting and end point. Let's do one more of these things. Okay, this one's a bit more curvy, but we can still go through the same process. So first imagine where we are going up on this roller coaster. So it looks like I have a little section here going from -5 all the way to 0. So increasing, -5 up to 0. Then my roller coaster goes down, it starts to go up again after 6. So 2 intervals for increasing, on to decreasing. So it's decreasing here, -infinity up to -5, and from 0 to 6. As for places that this place stays constant, I'm going to say none. So hopefully that helps you out, figure out where a function is increasing and decreasing. And this is an important topic which you will definitely need for calculus.